You have been watching a series of television programs on the CHEM Study materials for a beginning course in chemistry. As a result of these programs, we have asked you to send in questions that have occurred to you. And today we have a panel to discuss some of these questions. We won't be able to answer all of them, but here we think is a selection. Let me introduce first the panel. We have Mr. Warren McMillan, who is science consultant at the Los Angeles City Schools and was a teacher of chemistry at Monroe High School. Dr. Richard Merrill, who was executive director of CHEM Study for 3 years. Dr. A.L. McClellan, editor of the Teacher's Guide, who is doing research with Chevron Research Company. Professor George Pimentel, editor of the chemistry text and professor of chemistry at the University of California at Berkeley. Ms. Margaret Henley, chemistry teacher at James Monroe High School. Henry Kamada, chemistry teacher at Los Angeles High School. Orlando Powers teaches chemistry at John Fremont High School. And Gerald Garner, who is secondary science center specialist at the Los Angeles City Schools. Mr. Powers has the first question.
It is for you, Dr. Campbell. What is the range of student abilities for which teachers have found performance successful in chem study?
We haven't made any recent attempts to study this because so many students now are taking chem study that I think it is safe to assume of the several 100,000 students taking the course, it must be a very wide range of students who are taking it. There doesn't seem to be any correlation that one would expect with good students having trouble with the course or bad students not having trouble. What I really should say is that we don't find any difficulty with the poor students other than one would expect poor students would have. As a matter of fact, some of our early work, when we were very concerned with this program, indicated that the poorer students often did better than expected. Now, one of the problems that has come up occasionally is that some of the students you would expect to do very well indeed don't perform at the top of the class. We think perhaps we have changed the rules somewhat on the students, and that perhaps by playing down the rule of memory more than is customary in conventional courses, we may make it a little more difficult for students who rely purely on memory and make it quite a bit easier for people who have ways of figuring things out, who may not like to rely completely on memory. Thus, in general, I would say that there is no great change in student performance at the high school level from what we'd expect from other courses. But some students do better than would be expected, some do worse. I do think it pays to say that, by and large, student interest seems to be higher than it has been in other courses. How much of this is due to teacher interest and how much of it is due to the materials really exciting the students are very hard questions to separate. But no matter what the reason for it is, it seems true that students are more interested in the course, and we take great comfort in that.
Dr. Campbell, what suggestions can you offer for our chem study students who, in spite of having had algebra and maybe taking geometry, still have difficulty in understanding quantitative concepts?
I suppose that in every science course, since you must deal somewhat with numbers, students are going to have trouble with what we call quantitative concepts. As far as the degree of trouble, I think it pays to remind all of you who are teaching chem study and those of you who are considering teaching it that the degree to which algebra is used is not very great. There is some algebra used in the problems on gases. There is algebra used in the problems on equilibrium. But these are not a major part of the course. On the other hand, it is true that there is a quantitative emphasis throughout the course. In the laboratory, the students do experiments, most of which yield numbers. And the students, therefore, should have some facility in dealing with numbers. The arithmetic is really 7th grade arithmetic. It is not algebra primarily. I believe the thing to emphasize then with students is that they should get a feel for numbers, that one number is bigger than another number. And they should perhaps even more importantly get a feel that numbers can be attached to physical quantities that are observable, that it is possible to measure things in the laboratory and to come out with some numbers which can then be manipulated. There is another kind of problem that I would like to discuss briefly, and that is the student who comes in perhaps with this kind of quantitative reasoning but has some particular lacks. With this in mind, we have prepared 2 little pamphlets, one which has to do with the use of exponential notation. Many students can't use this very successfully. It is important for complete success in a course in chemistry to use it, so we have these program materials which can be given to the students, and they can be studied on the student's own time. In the same way, a student can save himself a very great deal of time if he learns to use a slide rule. and we have therefore a book here on slide rule use which can be given to the students. Both of these can be obtained, as can the Chem Study materials, from the Freeman Company in San Francisco.
Dr. Merrill, are statistical data on student achievement still being collected? What is the nature of such information?
Henry, we're not gathering any further data this year. The 1964-65 school year was the first year in which the Chem Study prepared students hit the colleges and universities in really significant numbers, and so we kind of put on a big push then. We have been looking primarily at the comparative performance of the Chem Study students in these freshman courses in some dozen or so colleges and universities of various types. As well as their freshman grades, we have collected data as to their high school chemistry grades, what kind of high school course they had, and some other factors such as whether or not they took physics and what the size of their school was and so forth. So we think that we may come up with some significant results. In fact, we have some preliminary results from this analysis. George, do you have some of that information?
Yes, we have placed some of the information collected by Dick on charts, and we'd like to show you some of these. I think these numbers will interest you very much. The first chart deals with an accelerated freshman chemistry course at the University of California at Berkeley, and entrance to this accelerated course depends upon performance in a competitive entrance examination. And the success of students entering the course is indicated by the numbers that you're looking at. Approximately 50% of the the Chem Study students score approximately 50% in contrast to 36% by traditional students. Now, needless to say, it's a difficult examination, and clearly the Chem Study students have an advantage. Now, more important is performance of Chem Study students at other institutions, and those are shown on the second chart. In the first place, a technical school provided us with some data on performance in their freshman chemistry course, and there we find, in terms of grade point average for a large number of students, that the Chem Study students were a couple of tenths of a grade point above traditional students. And then you see among the others, we have selected some of the institutions for which we have data, and there you see at the Naval Academy, at University of Florida and University of Minnesota, the Chem Study students had an advantage, and you won't be surprised, I'm sure, to see that at some institutions it's the other way. So one finds, depending upon the freshman chemistry course, a fluctuation, but generally speaking, the Chem Study student seems to enjoy an advantage. Now, we have one more institution which has provided us with data concerning an honors section, and that's shown on this chart. At the University of Minnesota, Chem Study students average some 3/10 of a grade point higher than traditional students. Now, at the other end of the spectrum are the students who have difficulty with the course and for one reason or another leave the course before the end of the course, dropout students. And the last chart we have here shows the statistics for the Naval Academy and the University of Florida. And with this rather small number of institutions for which we have statistical data, we find that the Chem Study students are showing more persistence. Now, we believe this is a very significant performance because it gives us some clue to the interest of students who are actually having difficulty with the course. And we would like to believe that these data show that students at this other end of the spectrum, which concerns us all very much, are actually carrying with them into their college chemistry course a significant amount of interest which shows up as persistence in the course.
Dr. Pimentel, why are atomic theory and chemical bonding left to the end of the course?
Well, Miss Henley, of course, you realize that the atomic theory is literally introduced in Chapter 1 and then used continuously through the beginning of the course. But we take up the more sophisticated aspects of the subject together with the whole problem of chemical bonding rather late in the course. So this is a legitimate question, and the decision to place this material at that point in the course was a very deliberate one. We believe that the whole subject of chemical bonding is a very abstract subject and one which has to be built upon a substantial foundation of experimental information and experience. We want the student to have some opportunity to accumulate a reservoir of knowledge about chemistry and chemical reactions on the basis of real laboratory experience before we get to this very abstract subject. Then we feel that he will get the best understanding of what science is all about and how these very abstract notions come out of laboratory experience.
Dr. McClellan, doesn't a detailed teacher's guide tend to limit creativity?
We believe that the cover of the book itself gives a partial answer, where it's called a teacher's guide. It is a collection of guidelines, not a set of absolute rules or dicta that must be followed. But to explain more fully, I would say that we need to consider two aspects of the word creativity. If you mean, does this limit the teacher who wishes to change the order of topics and to rearrange them, to put in others and leave out others, then in reality it does limit it, but really you're not talking about the Chem Study course. If the teacher makes these changes, it's another course that's being studied. Our suggestion here really is if someone is interested in the Chem Study material, that they try it for a year or 2 years so that they know thoroughly the order, the philosophy, why things were done that way, and at that point they might then be prepared to make changes which their experience tells them will give a better performance. But if by the word creativity you wish to remain within the structure of the Chem Study chapter, then I think, again, I would answer, it does not limit the creative teacher. And I would elaborate this by saying there are basically two types of information in the teacher's guide. One is of a routine nature. I'm thinking of the detailed instructions about preparations for the laboratories, lists of chemicals and supplies that the teacher can use in ordering, lists of supplementary material, the outline of the individual chapters. These are things which we feel most any teacher could do for themselves, but it takes their time, and we have done it for them, leaving them free to use that time to bring in other things, things which their teaching experience tells them are effective. The other kind of material you might call supplementary material. I'm thinking of the background material in particular, but also lists of extra books, other films, and so on. These are, again, guidelines that the teacher can put in if he has particularly interested students or capable students, if he has the background himself for this, and so on. I remind you that we directed the teacher's guide to the teacher who is less than ideally prepared, perhaps isolated at a school where there are no other chemistry teachers, and perhaps the school itself is not well equipped. That teacher cannot supply a great deal of material, and so we put it in. The teacher who does not have those difficulties can supply it themselves. Finally, I might say on this point that we feel creativity, the teachers could be improved by some ways that involve having a larger amount of time available for the subject. All in all, I think that the detailed teacher's guide was meant to help teachers, give them guidance, and we fully expect that they will add other things, do things in their own way. And in fact, I believe at the last panel show, there was some illustration of that. Was that not true, Art?
Oh, I think one of the main ways that a teacher can assert and exert some creativity is in the laboratory. After all, these are experiments, but no one is sure how a true experiment is going to come out. The teacher has to have some creativity, and we would certainly encourage any teacher to take full advantage of what has come to be called the open-endedness of modern chemistry experiments in the lab. You can go beyond where the lab presumably ends. In fact, the experiments are written this way. And last time, as you're suggesting, Miss Henley showed us how we could use the laboratory as a chance to demonstrate carbon dioxide generation from dry ice, how one could use an inner tube as a means of transporting gases from the shop where they have a large supply of certain gases up to the chemistry lab where they may not have very many. This kind of creativity can certainly be used by the teacher all the time. And if one keeps a creative atmosphere going in the lab, this is, of course, exactly what we're trying to do in any chemistry lab. Do real experiments where not only is the teacher creative, but where the student is creative. I think there are other ways, of course, thinking of gases for a moment, for generating them, besides the ways that were talked about last time. And we've got a little setup here which we can look at now to show how you can get some gases available to you in the Los Angeles system.
We have started by providing oxygen and helium. This is a cylinder of oxygen that I have here today. Through our central distribution of perishable materials, we're able to supply these to the school at a low cost for a 2-week loan period. The 4 1/4 cubic foot tank is adequate for a full day's use by all classes when you're doing experiment 6, where the students are working in pairs. It's very simple to use. We have a needle valve here which regulates the flow, and then it's just a matter of filling the plastic bag as we did before. And then placing it on the balance. One of the very important things is the nature of this container, which was developed in order to satisfy the possibility of safety hazard. It's an extremely rugged container, and the valve is well shielded and pretty well prevents the possibility of any sort of damage to the oxygen bottle or the delivery system itself.
It would probably be wise to emphasize this question of safety in the chemistry laboratory. Certainly in designing the CHEM Study experiments, a great deal of thought was put into making experiments which were as safe as they possibly could be. In fact, removing all the foreseeable hazards. This generation of oxygen is a particularly good example, I think. It used to be that most students learned to heat potassium chlorate, for example, and get oxygen. This really is a very dangerous experiment. The only explosions I've ever had in my own labs have been potassium chlorate explosions. I've got to the place now where I don't think any student ought to be allowed at the first year level to use potassium chloride as a source of oxygen. Even sodium peroxide is bad enough. So that now that lecture bottles are available, and so readily available, I would strongly encourage people to use this kind of system for generating gases. It's true the students may get the impression that oxygen comes in bottles, but that's a lot easier impression to get rid of than the impression that it's going to blow up in your face every time you heat something. Safety is extremely important, and it's very good to see the system moving in the direction of providing the teachers with such safe methods of getting important chemicals, like oxygen.
Dr. Merrill, what is the number of chapters considered a basic minimum?
I'd say 17. I think the basic integral structure of the course, which has been talked about before, really encompasses the first 17 chapters. Depending on how important you think chemistry of carbon is, perhaps an 18th chapter could be added to this absolute must list. As far as what you might skip or tread over lightly in order to get to some of the more descriptive applications at the end, it seems to me that I remember a lot of soul searching went in at the time the course was being put together at what kinds of things might be eliminated from this earlier integral structure, and that the things that remained did so because it was felt they would be seriously missed in the descriptive chapters if they were not there. So I certainly wouldn't skip any chapters. You might tread lightly over some of the ideas, and I think my candidates for what you might tread lightly over would be those ideas which are furthest divorced from the kinds of experiments which the kids can actually understand. I think some of the detail of the evidence that's presented for modern atomic structure may be evidence which students without physics background will not understand anyway. and you might sort of punt at this point and let them accept that on faith, hoping that they understand from previous work the inductive nature of the way we come to such information. I think we can look for one hope in this, and that is that as time goes on, the kind of preparation that these students will have had in their earlier work, in the elementary grades and in the junior high grades, will perhaps develop some of the basic concepts which will then be unnecessary to spend a lot of time on in chemistry, and we may be able to get to some of the fun chapters. One final thought, I surely would not shortchange the experiments, either cut out experiments as a way of saving time or spend insufficient time on them, because I believe these are the heart of the course.
Dr. Pimentel, what is the best way to use the remaining chapters on descriptive chemistry?
Well, we do believe that the course is best terminated with one or two of the descriptive chapters at the end. And we think that among the 5 or 6 chapters that are there, you should be able to find a couple that are of particular interest to you. Chapters which cover material about which you're enthusiastic and perhaps in which you can use experiments of special interest to you, possibly experiments which you are willing to have the students treat in an open-ended way. In this way, you get the opportunity to cap the course by covering material which interests you a great deal, and as you well know, this will immediately be apparent to the students. They will become interested if you're interested. You have the opportunity to allow the students some excursion into their own interests through open-ended experiments, and then you have finally the opportunity to put the principles to work so the student sees that the course has been going somewhere and now he's more powerful than he was at the beginning.
I have a question for you, Dr. Merrill. In your opinion, how important is the security of test answers and questions and experiment results?
Well, I have to say that the security is important simply because of the kind of premium that we put on getting the right answers in any course nowadays. This is a question which has frequently been asked me, both by teachers directly as today and in letters, and I don't have any really good answer for it, frankly. One has 2 conflicting things. If you go to the ultimate extent to try to protect the security of the test, you don't get the best pedagogic benefit out of it. I've always felt that it was a very worthwhile thing to spend perhaps half a period following a test going over the answers. And to go over the answers meaningfully, you have to go over the questions as well, so that even if the test booklets don't get away from you, the questions are out and pretty well known. As far as the laboratory results and this kind of thing is concerned, I think it's largely a matter of attitude. I know I always, at the end of the year, suggested to kids that don't pass your lab results down to the next generation for 2 reasons. One, look at all the fun you had, and why not let them make their own mistakes? And secondly, they really do contain a great deal of misinformation that we wouldn't want to pass on to the next class.
Dr. McClellan, is the laboratory most successful with students working in partnership or individually?
I feel that the individual approach is, in an ideal sense, the one that you wish to emphasize. In this way, the student gets to make his own observations at his own rate, in the order which he sees them. He gets the intellectual challenge of trying to decide what they mean without being pulled or carried or moved in any direction by someone else. On the other hand, I realize that there are sometimes reasons of expediency which make this impossible to carry out for every experiment. Just as Mr. Garner said, for instance, this oxygen supply is designed to suit for a day's use by people in pairs. And in the same way, other kinds of equipment are often scarce and require pairing them up. This then can be done, but I think you surely should try to have as many individual experiments as possible, and by showing group data, bring about the idea of uncertainty and differences in results. Finally, to return to an earlier comment, if the chemistry class had more time in the laboratory without changing the frequency of laboratory, then the teacher would have time to get around to the students who are working individually and help those who may have difficulty making the deductions I mentioned earlier.
Dr. Campbell, are teachers of Chem Study encouraged to get together to discuss questions and problems and boost morale, and how may this be implemented?
I should think it would be extremely valuable to get together. I know when I have problems in teaching, I have the great advantage in having a whole group of other chemists in the college and in town with whom I can discuss things. I understand that in many high schools, of course, there is only one teacher, maybe only two teachers, and you don't have much chance to discuss these problems. One of the best things a teacher can do is to get together with other teachers. Two heads are usually better than one, depending a little bit on the heads and where they are, on whose shoulders and how they're attached to the shoulders. But we would strongly encourage teachers to continue what we did in the earliest years, which is to get together periodically, discuss their problems. And as a matter of fact, the study itself would consider it a very good action on the part of the teachers if you could send to the study your comments that have come up. After all, these materials sometime may be revised, and it would be very wise to have some idea of how they are going now in your own classrooms. But even more important, I think, for your own personal use is to get together and see what's happening. Now, it's true there's a limited amount you can do about commiseration, but even commiseration is a good quality. If you're having problems, one of the best ways to minimize them is to get together with those other people. The way the Chem Study operates, I would guess most of you have found out that the first semester things are pretty discouraging sometimes. The teacher tends to get discouraged because the student tends to get discouraged. And perhaps this is the very best time for the teachers to get together. During the second semester, where we are now, we would hope very strongly that things are picking up a great deal, and that you and your students are considerably less frustrated than you were earlier, that you're beginning to see a pattern develop. And perhaps this is a good time then to get together with other teachers and find out whether similar patterns are developing in their schools and similar good results are coming out at the end. The most important thing, it seems to me, in a chemistry course is not what happens at the beginning or the middle, but what the student has learned and what he comes out with at the end. And getting together with other teachers could certainly help this. I hope, too, this whole series has been helpful in this respect, that you have found both the little talks and the films useful to you in teaching your own course. As questions arise, don't feel that just because the series is now going to stop, the questions have to terminate. Send them in to the system or to Chem Study.